50%. Just let that sink in for a second. A major study found that, as individual programmers, we actually catch less than half the bugs in our own code. And those traditional testing methods we usually lean on, they're only grabbing about 35%. So if we're just trusting our gut to say, yeah, this code looks good, we are literally missing more than half the picture. We absolutely have to get some objective tools and strategies in place to stop the bleeding here.
So, welcome to The Explainer. I am so incredibly pumped you're here today. Our goal is straightforward, but honestly a total game changer. We are going to transform how you build software by auditing, measuring, and finally crushing that technical debt. If you are sick and tired of playing whack-a-mole with old bugs instead of, actually building cool new features, you are in exactly the right place. Let's get into it.
Okay, here's our game plan for today. We're going to kick things off with the technical debt snowball. Then, we'll define what true code quality actually is, look at the metrics that genuinely matter, dive into some awesome automated tools, and wrap the whole thing up by mastering the human side of this, the code review. Let's go.
Section 1. The technical debt snowball. Let's look at why taking the easy road now is going to cost you big time down the line. Technical debt. You know the term, and it is exactly what it sounds like. It's basically a financial metaphor for software development. It's the future cost you get slapped with when you take an easy, quick and dirty shortcut today instead of doing it the right way, which, takes a bit longer. It's literally like maxing out a credit card. Sure, it feels like a lifesaver when you're staring down a crazy deadline, but if you don't pay off that principal, the interest starts compounding. And soon, that interest generates its own interest. Before you know it, you've got this massive snowball rolling downhill, and your devs are spending all their time just paying off the interest, fixing bugs, rewriting messy code, instead of actually adding value.
So how does this pile up in the first place? Well, I bet a few of these are going to hit a little close to home. The number one excuse: tight deadlines. We've all been there, right? The pressure is on, so you just copy-paste a chunk of code instead of refactoring it properly, just to avoid running full regression tests. But there are other massive culprits too. A total lack of coding standards, those terrifying monolithic classes nobody wants to touch, over-engineering stuff you don't even need, or just leaving dead code lying around because everyone's too scared to delete it. Every single time a rushed hack gets pushed through, you are taking a huge loan out against your future productivity.
Moving right along to Section 2, Defining True Code Quality. Since we already established we can't really trust our own biased opinions on our code, it's time to bring in the auditors.
Here's the thing. We can actually take this fuzzy, abstract idea of quality and break it down into hard, measurable traits. Instead of just guessing, we look at reliability and maintainability. That means tracking real data like mean time between failures, overall complexity, and style warnings. We also look at testability, like can we actually isolate and automate tests for this thing? Then we've got portability and reusability, making sure our code survives in different environments and doesn't have a million messy interdependencies. We are taking the guesswork out of this completely. No more, I think this looks okay. We want hard facts.
Section 3. Metrics that actually matter. And speaking of hard facts, let's look at the numbers.
If you want to know if your software is financially healthy or about to go totally bankrupt, you've got to watch your critical KPIs. We're talking failed bill percentages, failed deployments, and your overall customer ticket volume. But honestly, one of the most revealing metrics is your bug bounce percentage. Basically, how often are your bug tickets getting reopened because the fix didn't actually fix anything? And then there's your unplanned work percentage. When you track these operational numbers in a modern DevOps setup, you spot the bleeding way earlier in the pipeline, which means it costs way less time and money to patch up.
Now, I want to briefly touch on two specific terms that feed into those metrics: cyclomatic and Halstead complexity. Cyclomatic complexity is pretty simple. It just counts the different paths through your source code. More paths usually mean it's a nightmare to test. Halstead complexity, on the other hand, looks at the whole shebang. It measures vocabulary, length, volume, and the actual brainpower effort required to understand the code. Together, these mathematical models strip away all our human biases and show us exactly how structurally sound our work really is.
All right, Section 4, Automated Code Quality Tools. If tech debt is a financial crisis, consider these tools your automated financial planners. Let's look at who's doing the heavy lifting. To stop that debt from constantly piling up, automated assessment isn't just nice to have, it's absolutely non-negotiable. Take a tool like SonarCloud. Think of it as your master dashboard. And it doesn't just scream at you that your code is broken, it actually gives you a clear rundown of the problem, hands you step-by-step instructions to fix it, and, get this, even gives you a time estimate for the repair so you can actually plan your sprints. It's essentially a robot accountant catching your bad spending before it ever hits the ledger.
Next up is GitHub Advanced Security, or GHAS. Now, GHAS gets a lot of hype as a security tool, but let me tell you, it is an absolute beast for hunting down technical debt. Think of it as your intelligent security detective. It finds design flaws and vulnerabilities way before they mutate into architectural debt that bogs down your whole team.
GHAS essentially runs on three main pillars. First, you've got code QL analysis, which automatically scours your code looking for nasty patterns, coding errors, and design flaws. Second is dependency scanning. Outdated dependencies are a huge silent killer, right? But GHAS uses Dependabot to just automatically create pull requests to update those vulnerable packages. It literally does the heavy lifting for you. And finally, general code scanning. This checks for straight-up security vulnerabilities, like SQL injection, plus general code smells that scream bad design.
Now, for my .NET folks out there, let's talk about Independ and ReSharper. These two are an absolute must. They enforce team standards right inside the workflow you're already using.
I'm not kidding when I say these tools give you superpowers. With Independ, you can literally write your own custom quality checks using familiar C# LINQ queries. And incredibly, you can track the technical debt you're adding in real time, down to the hour. Then you've got ReSharper. You can set it up to automatically fail a build if the code quality is garbage. That is huge. It acts like a literal brick wall, stopping bad code from ever seeing production and forcing everyone to stick to the team's standards. Moving to our final section, mastering the code review. Because look, tools are amazing, but at the end of the day, technical debt is a human problem. We have to fundamentally change our spending habits.
There's a night and day cultural difference in how teams handle code reviews. Honestly, a lot of places run them like interrogations. You get a huge, stressful group meeting where everyone's just trying to find fault and blame the author. It's toxic, and it just makes people defensive. The right way? Treat it like a mentoring session. Small groups, maybe 2 or 3 people tops, share knowledge openly, and treat mistakes like the learning opportunities they actually are. When developers feel safe, they write better code. It's that simple. And that's exactly how your software wealth grows.
So, in these mentoring sessions, what are we actually looking for? Well, reviewers should be asking, is this readable? Is it easy to maintain? Does it follow our team's standards? Are there obvious ways we could make this more efficient? Did they use secure coding practices? And crucially, is this code testable? By hyper-focusing on these 5 areas in a supportive, positive environment, you literally stop the debt snowball right in its tracks. All right, let's bring it all home with the debt management strategy. This is your actual, actionable path to a wealthy, healthy code base.
To pull this off, you need a 4-step blueprint. Step 1. Set your quality gates in the pipeline. Define your absolute minimum standards and do not budge. Step 2. Prioritize. Don't try to boil the ocean and fix everything today. Knock out the high-impact, high-risk debt first. Step 3. Track your progress. Use those automated dashboards we talked about to watch your debt trends over time. And Step 4. This is the big one. Allocate reserve time in every single sprint explicitly for reducing debt. Listen, if you don't budget the time for it, it is never going to happen. You have to make debt management a totally normal, seamless part of your everyday DevOps routine.
As we wrap up this explainer, I've got one question to leave you with. What is the true cost of your next quick fix? Seriously, the next time the pressure's on and you are so tempted to just take that shortcut, remember the interest. It is going to compound. Lean on your metrics, let the automated tools do their jobs, and build a culture that actually values long-term quality over just shipping something fast. Trust me, your future self and your future code base will absolutely thank you. Thanks for hanging out with me for this explainer, and happy coding.